I hope that I find you well. This is Kumbulani Ngwababa, the founder of eSchool, and I'm your math tutor online. Today we're going to be talking about kinetic theory of matter, just a short discussion, and we'll be focusing mainly on gases. Okay, and the ideal gas equation, I don't know if you remember this one from your high school. PV is equal to nRT. P is the pressure, V is the volume, N is the number of moles, R is the ideal gas constant, and T is the temperature. Okay, so let's just take a look at the states of matter that you know. You know that in matter consists of particles. Okay, so they say nature has a particulate matter has a particulate nature. Okay, meaning that matter consists of particles. Okay, and depending on whether it's a solid or a liquid or a gas, okay, the force between those particles varies depending on the nature of the matter. Okay, so we can measure the relative temperature or pressure or the volume of a particle. Okay, and that can help us to determine whether it's a gas or a liquid or a solid. Okay, now if you talk about gases, in gases, the gaseous state, okay, the average separation between the molecules or the particles is large compared with their dimensions. Okay, and the molecules obey laws of motion, but as a whole they're in random movement. Okay, right, in a gas the molecules interact only by short range forces and they encounter elastic collisions. Okay, the molecules or the atoms or the particles in a gas make elastic collisions with the walls, and the gas under consideration is a pure substance, that is, all molecules are identical. So that's the assumption that we use when we're making calculations based on the molecules or the atoms in a gas. But when you look at the solid state, okay, let's look at the solid state. In the solid state, let's just go back a bit. In the solid state, the particles are tightly packed, okay, and they only vibrate to and from, okay, in a small, very small distance from their center of vibration. Okay, but if you hit the particles, the vibrations get larger, and in a solid, if you hit it to a certain temperature, which is called the melting point, okay, a liquid can then form. For example, changing ice to water. Okay, so you notice directly here it goes from solid to liquid to gas if you apply a certain amount of heat. Okay, so also in liquids are composed of particles, the same particles that are in the solid, but now the difference is that they have movement to freely move or slide over each other. They have more energy that is transferred to them compared to the solid particles. Okay, and further, if you hit the liquid particles, okay, which are slow moving, they become faster, and then eventually they get enough energy to escape from the container and they become gaseous. Okay, and that when that happens we call it boiling. When a liquid is heated, its particles get more energy and move faster. They bump into each other more often and bounce further apart. This makes the liquid expand. At the boiling point, the particles get enough energy to overcome the forces between them, and they break away to form a gas. But please note, don't confuse boiling and evaporation. Okay, those are two different phenomena. Okay, in evaporating, some particles in a liquid have more energy than others. Okay, even well below the boiling point, some have enough energy to escape and form a gas. This is called evaporation. Okay, it is why puddles of rain dry up in the sun. Okay, it's due to evaporation. So let's just quickly look at a simulation of the kinetic theory of matter. Okay, this is a simulation or a virtual experiment, okay, which will show us what happens when a liquid is cool. As we said, the atoms are vibrating to and from about their equilibrium positions. They are also vibrating randomly, okay, but with the naked eye you cannot see them. Okay, and what happens when you heat up that solid? The vibrations, according to the particle kinetic theory of matter, gain more kinetic energy. The particles gain more kinetic energy, and then they start sliding and moving over each other. Okay, so in this state, as you can see, that's the liquid state. Okay, the more and the further the heat is applied, when the temperature increases further, you can see some of the particles will be free to break the forces of attraction between them. Okay, and you can see they're now encountering those elastic collisions with each other like billiard balls, okay, or pinball. I don't say that in the examination, but more like billiard ball motion. Okay, if we're to open up this container, then somewhere there, it's just that it's a closed container. If we're to open up this container, then the particles will be free to all boil out and to move out with high velocity, okay, until this container is totally empty. This is what happens when you heat up your water in a jug in the morning. Okay, you saw what happens. First of all, it looks like the liquid is not moving. Okay, of course, in essence it will be moving, but the movement will be very minute. Okay, very small speed, at molecular level speed. But the more heat that you apply to it, and the more energy you transfer to the particles of the substance or the matter, and the more energy they have, it means they will be able to break the forces of attraction between each other. Okay, because the kinetic theory of matter states that the reason why they are stable, the particles don't move away from each other. Okay, they have a stability, they're in equilibrium. Okay, they do vibrate, but they vibrate around an equilibrium position randomly, and they don't move away from each other because the forces of attraction between them were designed to keep them stable. Okay, so that's just the kinetic theory or the molecular model of matter. Some notes that you can write down. In a solid, any energy supplied to it causes the molecules to oscillate more wildly about their mean position. Once the molecules have enough energy to break their bonds, okay, with their neighboring molecules, they are free to move away from their original place. This is what happens when a solid melts. Once the entire solid is melted, any further energy supplied to the molecules causes them to move around faster. If enough energy is supplied to the liquid, the molecules will eventually get enough energy to break away from the surface of the liquid entirely and so become a gas. This is called evaporation. Okay. or boiling, okay, depending on how much, whether or not the molecules or the atoms have reached boiling point. Evaporation can actually happen at a lower temperatures, but happens most furiously at the boiling point. When the gas is allowed to cool down sufficiently, it will start to condense back into liquid and then ultimately back to a solid. Okay, so if we cool down our substance, you see we've removed the heat. You see the opposite of what was happening happen. Eventually, the average velocity of the particles slows down, and the kinetic energy that they had of motion is converted to heat, okay, which is lost to the surroundings of the container and to the atmosphere, okay, and then eventually there'll be less vibration, smaller vibrations about their equilibrium position, which you won't even be able to see with your naked eye. So basically, that's just a short description of the kinetic theory of matter, or the molecular model of matter. Okay, I hope that you enjoyed this tutorial. This tutorial was brought to you by the Math Tutor Online. Okay, for more in-depth tutorials, you can contact me or hit me up on my Skype, or you can hit me up on my telephone, and I'll be willing to get back to you as soon as I can. Okay, so in our equation, ideal gas equation, PV is equal to nRT, please bear in mind that this R is known as the ideal gas constant. Okay, there it is, the gas constant, and it has a value of 8.31 joules per mole per Kelvin. And we say this N represents the number of moles, which is the mass of the substance divided by the molecular mass. Okay, this T will be the temperature, this V will be the volume, and P will be the pressure. Okay, so depending on what information you are given, you can easily calculate one of the required variables. Thanks for watching this tutorial, and enjoy your study.